Hey everyone, welcome to AIMAX College. Today we are going to start a series of lessons to learn grade 11 functions, a practical and hands-on approach for you to go exactly from an absolute beginner to test level. We will start with domain and range. Domain and range. Before we jump into grade 11 functions, I want to make sure you have everything you need to succeed. By the end of this video, you will understand 6 foundational concepts that every MCR3U student needs before lesson 1. Things like ordered pairs, set builder notation, and why dividing by 0 breaks math. The pre-handout in the description has the lesson summary and a 3-level drill: beginner, intermediate, and exam ready. So you can test yourself right after we cover each concept. Let's start. Think of this video as your toolkit. We are going to cover 5 quick things: the coordinate plane, ordered pairs, tables of values, inequality symbols, and what happens when you divide by 0. We will add some essentials on notation as well. We will discuss briefly on writing domain and range using something called set builder notation. If you already know all of this, great. Use this as a review. If some of it is new, perfect. You are in the right place. Let's go. Let's move to discuss the first one, the coordinate plane. The coordinate plane. Let's start with the coordinate plane. Look at the board. Grid sheet or graph sheet. X-axis, and y-axis. Label the x-axis and label y-axis. Y-axis is vertical axis. This plane is called the Cartesian plane. It has 2 lines, a horizontal line called the x-axis and a vertical line called the y-axis. They cross at a point called the origin. The origin has coordinate 0, 0. The origin has coordinates 0, 0. Coordinate is 0, 0. The plane is divided into 4 sections. The plane is divided into 4 sections. We call them quadrants. Quadrant 1 is top right. Top right is quadrant 1. Both x and y are positive here. Both x and y are positive in the first quadrant. Quadrant 2 is top left. Quadrant 2 is where it is top left. X is negative here. Y is positive. X is negative and y is positive. So what would be the quadrant 3? The quadrant 3 is bottom left. Bottom left. Quadrant 3. Both negative. Both negative. X and y are negative. Quadrant 4 is bottom right. Quadrant 4 is bottom right. So the x is, what is x? X is positive and the y is negative. X is positive and y is negative. So we have Q1, Q2, Q3 and Q4 on this Cartesian plane now, on the diagram now. You don't need to memorize the quadrant names right now. What you need to know is this: every point on this plane has an address. Every point on this plane has an address. That address is called an ordered pair. That address is called an ordered pair. Ordered pair. Here is a better view of a coordinate plane. This sheet is called grid sheet or a graph sheet. And here is the Cartesian plane. And this is the x-axis. And here is the y-axis, vertical axis. And here is the 0, 0, the origin. And those are the quadrants. Q1 is here. Q2 is here. Q3 is here. Q4 is here. So we talked about a ordered pair. So this one is an ordered pair, ordered pair, ordered pair, 2, 3, 3, 1, minus 3, 1. Is another ordered pair, minus 1.5, minus 1.5, minus 2.5. So those are the ordered pairs. Number 2, ordered pairs. An ordered pair looks like this: x, y, x, comma, y. Close brackets, parenthesis or close brackets, x, y. It's two numbers inside brackets separated by a comma. The first number tells you how far to go left or right on the x-axis. The second number tells you how far to go up or down on the y-axis. Let me show you. The point 3,5. Start at the origin. Go right 3. Go right 3. Then go up 5. Go up 5. Put a dot. That's your point. Point 3, 5. Now, let's try minus 2, 4. Minus 2 plus 4. Start at the origin. Go left 2 because it's negative. Go left, that means minus 2 because it is negative. Then go up 4 plus 4 and dot. Minus 2, 4. One more. Minus 3, minus 5. How to plot that? Minus 3, minus 5. Go left 3 and go down 5. Go left 3 and go down 5. Minus 3, minus 5. Now, notice the order matters. 3, 5. 3, 5 and 5, 3 are two completely different points. That's why we call it an ordered pair. An ordered pair. There is an order. 3. Tables of values. Tables of values. This is how we find points to graph an equation. Graph and an equation. Say I give you this equation. Y equals 2x plus 1. Y equals 2x plus 1. A table of values is just an organized list. Tables of values are organized list. Like this. It's a table. On the left side, a table of values is just an organized list. On the left side, I pick x values. X values are here. On the right side, I calculate the y values by substituting into that equation. Y values by substituting into that equation. Here is x and here is y. Let's use x equals minus 2. Minus 2. Okay, let's take x minus 2 minus 1, 0, 1, 2. So x values are minus 2, minus 1, 0, 1 and 2. These are the x values. When x equals minus 2, when x equals minus 2, then the y is 2 times minus 2 plus 1. So what is that value? 2 into 2 is minus 4 plus 1. Minus 4 plus 1 is minus 3. So the ordered pair is minus 2 minus 3. Minus 2 minus 3 is the ordered pair. X is minus 2 and y is minus 3. When x equals minus 1, x equals minus 1, y equals 2x. 2, x is minus 1 plus 1. This is minus 2 plus 1. So the value is minus 1. Y equals minus 1. So the ordered pair is minus 1 and y is minus 1. Minus 1, minus 1 is the ordered pair. X is minus 1, y is minus 1. What will happen if x is 0? X is 0. Y equals 2x plus 1. 2, 0 plus 1. So this is 2 into 0 is 0 plus 1 is 1. Y equals 1. So the ordered pair is 0, 0, 1 is the ordered pair. 0, 1. When x equals 2, x equals 2, y equals 2x plus 1, 2 into 2 plus 1. 2 into 2, 2 times 2 is 4 plus 1, value is 5. So I forgot this one. 1, when it is 1, okay, let's do that. When x equals 2, it is 5. When x equals 1, y equals 2 into 1 plus 1. 2 into 1 is 2 plus 1, y equals 3. So this one, when x is 1, y is 3 is 1, right? 0 to 1, 1, 3, 2, 5. I forgot to put this 1 here. Up to 2 minus 2 plus 1 is minus 1. And let me divide this. This is x equals 2. This is for x equals minus 2. This one is minus 1. X equals minus 1. 0. X is 0. X is 1 here. All over the place. X is 2 here. So that is the this is 1 here. And I can complete the table now. So this is the equation. This is the equation, and here are the values for x. Values for x, and these are the assigned substituted values. Oh, here is the snapshot of what we have done with that equation and the values of x. Let us put y for all the answers for each values so that it is not confusing. So this is the table of values. Table of values. This is the equation that we were using, that we considered, and these were the x values. So the table of the values, all x values and y values based on the equation here. Y equals 2x plus 1. So we got -2. The ordered pair is -2, -3, ordered pair. Ordered pair. The ordered pair. -2, -3, -1, -1, 0, 1, 1, 3, 2, 5. Now, we are going to plot all 5 points and connect them. There are 5 points here, and plot on the Cartesian plane and connect them. -2, -3, -2, minus, this is x value, -2, x is -2, -2 here, and -3 for y value. -2 here and -3. These are the y values. -3 is here. This is the point. -2, -3. And -1 and -1. -1, x -1 is here, and y -1. So that is the, here is the point. -1, -1 is here. Let me write it properly. -1, -1 is here. Oh, should not do that. -1, -1, -1, -1, -1. This is the point. -1, -1. And next point is 0, 1. 0 is here, and 1, 1. Y is 1. 0, 1. That's the ordered pair. 0, 1. 1, 3. 1, 3. 1, 3. That's the order pair. 1, 3. And 2, 5. 2 is x, 2, and 5. 2, 5. Now I'm going to connect this. I'm going to connect this one, and this one. Let's connect this. Here we have a 0, 1, right? 0, 1 here. So this is a straight line. This is a straight line. This is exactly what you will do in the main lesson when we investigate y equals x, and well, what I drew was not straight. You have to assume that y equals x squared. So practice this. We are going to do y in the main lesson. In the main lesson, we are going to do y equals x and y equals x squared in the main lesson. So practice this one. Practice this tables of values. Next, inequality symbols. You will see these constantly in domain and range. Let's decode them once and for all. Greater than, greater than. The symbol that opens to the right, to the right. Five is greater than 3. 5 is greater than 3. This is true. This one is true. Less than, less than. The symbol opens to the left. 2 is less than 7. 2 is less than 7. This is true. Greater than or equal to. Greater than or than or equal to. Greater than or equal to. What is the symbol? Greater than or equal to. This symbol has a little line underneath. This line underneath. X is greater than or equal to 0 means x can be 0, 1, 2, 3 or even 100. And the 0 is included. 0 is included. Less than or equal to. Less than or equal to. Less than or equal to. Same idea. X less than or equal to 5 means x can be 5, 4 or 3. 4 or 3. Or negative a million. So x is x less than or equal to 5, x can be 5, 4, 3, 2, like that. And finally, not equal to. This symbol, not equal to, not equal to. This symbol is an equal sign with a slash through it. X3 means x can be any number except 3. X can be anything except 3. X can be anything except 3, excluding 3. Here is a memory trick for greater than and less than. The small pointy end always points to the smaller number. Always pointing to the smaller number. Always pointing to the smaller number. 5 greater than 3. 2 is less than 7. The small pointy end always points to the smaller number. Always point to the smaller number. Less than 7, the point aims at 2. This point aims at 2. In 5 is greater than 3, the point aims at 3. The point aims at 3. Which is smaller? Which is smaller always? This one is smaller always. So that's the memory trick to remember. Five. Division by 0. Undefined. Last thing, and this one is really important for functions. What is 10 divided by 2? That is 5. Easy. 10 divided by 2 equals 5. What is 10 divided by 1? What is 10 divided by 1? It is 10. 10 divided 1 is 10. Now, what is 10 divided by 0? 10 divided by 0. What is 10 divided by 0? Take a moment. Think about it. Let's say that is some number. I'll denote it as Sm. Some number. Sn. Let me Sn. Sn. Some number. 10 divided by 0 is some number. If 10 divided by 2 is 5, that means 5 times 2. 5 times 2. 5 times 2 is 10. 5 times 2 is 10. And 10, this answer 10 times 1. 10 times 1 is 10, right? So we can check division with multiplications. Now, in the same case, if 10 divided by 0 is a sum number, that number times 0 should equal to 10. This Sn, sum number, into 0 into sum number into 0 should equal to 10. This is 10, this is 10. This sum number times 0 is 10, should be 10, right? Should equal to 10. But anything times 0, is 0, right? So this is not equal to 10. There is no number that works. There is no number that equals to, there is no this Sn number that equals to 10 when multiplied by 0. So we say this is undefined. We say this one, this is undefined. This one undefined. In functions, whenever the variable x appears in the bottom of a fraction, in the denominator here, we have to make sure the denominator is never 0. Denominator never 0. That's where restricted domains come from. We will see this in the main lesson. If y equals 1 over x minus 3, then this should not be 0, right? Then x is not equal to 3 because denominator can't be 0. Because denominator can't be 0. This is the denominator. Denominator can't be 0. Denominator can't be 0. We were talking about undefined. What is undefined? Division by 0 is undefined. Let me explain this little bit further. What I said is, if y equals 1, if y equals 1 over x minus 3, then x is not equal to 3 because denominator can't be 0. What is this denominator? We are talking about a denominator because this is a fraction. This is a fraction. Fraction. So, as an example, this is a fraction. 3 over 4 is a fraction. I have mentioned here, identify the numerator and denominator. So, we were talking about the denominator. Denominator is this one. What is the number? Bottom number. This is the denominator. And there's another one called numerator. This is the numerator on a fraction. Now, this one was our equation. So, y equals 1 over x minus 3. This is a fraction. Now, we have mentioned that yx is not equal to 3. How to explain that? Let's say that x is 3. X is equal to 3. If x equals 3, then what happened? X minus 3 is, when you substitute x here, 3 minus 3 minus 3 is 0. X minus 3 is 0 then, right? X minus 3 is 0 then. Then what happened to this equation is y over x minus 3 has become 1 over 0. This is what we said undefined. This is what we said undefined. This one is undefined. So, x cannot be 3. In functions, whenever the variable x appears in the bottom of a fraction in the denominator, we have to make sure the denominator is never 0. That's where restricted domains come from. The denominator is never 0. Whenever variable x appears in the bottom of a fraction, variable x is appeared in the bottom of a function, this is a function, the denominator, in the denominator, we have to make sure that denominator is never 0. Never 0. That's why that x is not equal to 3 here. I hope that is clear now. 6. Set builder notation. One last thing, notation. In this course, we write domain and range using something called set builder notation. It looks scary. It's not. Let me write one. Curly bracket, x, epsilon, r for real number, and such that, that's the vertical bar, such that x greater than or equals 0, and closing the curly bracket. Curly bracket, x, epsilon, real number r, such that the pipe, vertical bar, x greater than or equals 0, closing the curly bracket. Sometimes it may be difficult for you to recognize my handwriting. So, because this is not all English, this is some other alphabetical notations. So, therefore, I have typed it to explain. Here it is. This close bracket, this curly bracket, let me read this to you in plain English. The curly brackets mean the setup. The x epsilon r means x is a real number. meaning x can be any number on the number line, including decimals and fractions. The vertical bar means such that. The vertical bar means such that, and x greater than or equal 0 is the condition. This epsilon or the character like e denotes as is an element of or is in or belongs to based on the application. So epsilon is, we can say the epsilon is an element of, is in, and or belongs to. Is an element of, is in, or belongs to. So the whole thing reads as the set of all real numbers x such that x is greater than or equal to 0. In other words, any number 0 or bigger. So this is what is it in plain English. The set of all real numbers x such that x is greater than or equal to 0. In other words, any number 0 or bigger. Let's try one more. Curly bracket, y, epsilon, r, real number. The condition, no, such that y does not equal to 2 and close bracket. Let me explain that. The setup, the set of y is a real number such that y is not equal to 2. The set of y is a real number such that y does not equal to 2. The set of all real numbers y such that y does not equal to 2. That means any number on the entire number line except 2, without 2. So in other words, the set of all real numbers y such that y does not equal 2 means any real number except 2. Any real number except 2. We will discuss these in detail in the future as well when we are dealing with the math problems. That's the notation. You will use it every single lesson this semester. So let it sink in. Recap. Alright, let's recap what we covered in this video. 1. The Cartesian plane has an x-axis and y-axis. They meet at the origin. 2. Ordered pairs are written as x, y. First number goes left or right. Second number goes up or down. To build a table of values, substitute x values into your equation to find y. 4. Inequality symbols: greater than, less than, greater than or equal to, less than or equal to, and not equal to. Number 5. Dividing by 0 is undefined. Any x that makes the denominator 0 must be excluded. Number 6. Set builder notation reads as the set of all real numbers x such that the condition. This is your handout for today, for the today's lesson. And there are some exercises with answer keys so that you can try. Also, you are given with some progressive drill sequence for the video 1, the today's video, and this will be continued for each and every video. These are the drills. This is a level 1 and level 2 drills and level 3 exam ready drills. So the drills are there and the answer keys are there, and you will get a graph sheet as well. You can try them before the first lesson 1, and we will discuss these later, and before that it's better to do them. So ready for the main lesson? First, do the drills on your handout. Download the handouts from the description or comment section. Then watch the video 2, domain and range. That's all for you today. We will meet again with the main lesson video followed by progressive exercises and drills video soon. Please comment, share and subscribe so that you will not miss any future videos. We are covering AI, maths, science and English for absolute beginners here. If you need any special help on grade 11-12 maths and science, business math test and English test preparation for college entrance, please contact us. Also, if you need any help online on understanding AI or using AI for any of your daily works or professional works, please do contact us. Comment below for any special requests to cover during the videos. Thank you so much. We'll meet again. Bye bye. God bless.